right, our first topic in chapter 1 is going to be set and interval notation. So set notation is probably what you're used to from algebra class. For instance, in a range of numbers from -2 to 10 in this first example, you would have written something like this. You're saying, oh, x is between, so it's less than 10 or equal to because of the filled in circle. And on the other side, you would have this means that x is above -2. So when you write that, you're saying x is greater than or equal to -2, but kind of flip it around in your mind, and what it does is it goes on the other side of the x right here. And so my negative kind of ran into my problem there. All right, so anyway, so this is how you write set notation. You're saying x is between. And when you are writing something, this is called a compound inequality. These inequality symbols always face this way. They always go like this with the x in between. And they could have equal bars or not, but then you always put the smallest number on the left and the largest number on the right. And so that's the proper way to write a compound inequality. So when you do set notation, you say this. You start a set, like a little fancy bracket, squiggly bracket, and you say x is an element of the real number system, because our numbers here are real numbers, and you can have other things there, but for now we're doing real numbers. And then you write this line and you say such that, and then you put exactly what you've written here. You say x is between or equal to -2 to 10. Okay, so what we're going to do is go ahead and write the set notation for each one of these things, and then you can, we'll do the interval notation separately. So here, this next one is broken, so you can't write it together as one big piece like we did before. So it's like two separate problems. X is bigger than 5 or x is less than -1. You can't put these together. This one up here is like an and statement. You would say that x is less than or equal to 10, and x is greater than or equal to -2. So those come together. So saying those two things together is what this really says. So down here, what we would say, we say x is an element. It's a little funny looking E. It kind of is like a half circle in a way, and then a line like that, such that, element of the real numbers, such that, and you literally list each one. You say x is less than -1, and you put the word or, x is greater than 5. And that or kind of tells you you have a broken area. All right, so down below, another compound area here. So x over here is between, we got -4 on the left and 6 on the right. So there we go. X is an element of the real numbers such that x is between -4 and 6. And I suppose every once in a while, you know, like this circle could be open and then this one could be filled in. So you could have an equal bar here and not there, but it's kind of more normal to have them be similar. All right, again, this is broken. X is greater than or equal to 4, or x is less than or equal to 2. So we have x is an element of the real number system such that x is less than or equal to 2, or x is greater than or equal to 4. All right, now when you have no solution, set notation is great, because you basically do this. You draw a set and you leave it empty. It's empty. You leave that empty because there are no answers. X is not even a real number, like it's nothing. Okay. And when you have all real numbers, you can write it a couple different ways. You could say this: x is an element of the real numbers, and then stop, because literally there's no conditions. This area back here is basically for a condition on what the real numbers are. So you're just basically saying x is a real number, any real number that you want. Okay, or you might see it written like this. You could see like x is between -infinity to infinity. You could see it written like that. Yeah, just different ways. You never put an equal bar with infinity symbols because you can't ever actually reach infinity. You know, you never reach it. It just keeps going. Now for intervals. Intervals is a little bit easier to write, and it's kind of more preferable usually when we get into upper level math. So interval notation, basically what you do is you're going to be using brackets to indicate that you want a number. Brackets mean equal sign. Parentheses mean that you don't equal something, right? Like you don't want something, but you're going right up to it. So when you have an open circle like this, you'll be using parentheses because it's not equal to that number. But when you have a closed circle like this, then you're going to be using brackets. Okay, and anytime you're going off to infinity, you'll see that in the problem, or maybe you're going to negative infinity. You'll see that there as well. All right, so we have a nice closed area between -2 and 10. So I'm going to say -2, comma 10, and put brackets on each because it's equal to either of them and between them. So basically what you're doing here is you're putting your low number and then your high number. Your low and your high, and then you're putting brackets or parentheses depending on the dot. All right, so this is where it gets a little bit annoying here. We have everything less than -1. So if I'm going from less than -1, it means I'm having from negative infinity to -1. So negative infinity is a smaller number, and -1 is a larger number. So that's one area. And then over here, I have another area from 5 up to positive infinity. So they're like two broken areas. It's like two problems. These do not have a filled in circle, so parentheses. And infinity, like I said earlier, never gets a bracket. It always gets parentheses. And so same here. And this word or. So when you write this word or in interval notation, you put this little union symbol. Okay, so or. All right, because remember from geometry, this means and this one means or. All right, here, everything between -4 and 6, so -4 to 6, both parentheses, because they're not equal to, and so those are nice, easy things to write. A broken one again, so this one's coming from negative infinity and stopping at 2, but a bracket on the 2, and parentheses on the infinity, or then I have a bracket on my 4 and up to infinity. Okay. An empty solution. There is no interval notation for an empty solution because there's nothing to write because it's empty. For all real numbers, you got from negative infinity to positive infinity, and you end with parentheses. Okay, that's it. Our next topic will be, right? Yeah, okay, there we go. All right,